So finite automata. So actually, FA, finite automata, is the simplest form of machine to recognize the given pattern. So it is the simplest form compared to all other types. Finite automata is a very simple. Okay, so it is the simplest form to compare or to recognize the given pattern. Fine. So and obviously it is an abstract machine. I have given enough definition about this abstract machine, why we call the finite automata machines or abstract machine. The very first class itself I gave a definition for the abstract machines. So it is an abstract machine, and we the finite automata, actually it has been classified into major two types: finite automata with output and finite automata without output. Finite automata with output and finite automata without output. In finite automata with output, we have two category of machine: Mealy machine and Morley machine. Mealy machine and Morley machine. Fine. And finite automata without output is categorized into three types: DFA, very important: deterministic finite automata, non-deterministic finite automata, and epsilon NFA, epsilon non-deterministic finite automata. See, this part is not covered in your syllabus actually. So this is what we are going to discuss in the first unit. Fine. So finite automata is the type 0 class, belongs to Chomsky hierarchy, and it is abstract machine which it is an abstract machine which is very simple to recognize the given pattern, whether the given pattern can be accepted or not. So the machine structure is so simple, and it is the least type class, belongs to the Chomsky hierarchy. Fine. So I hope you understand the classification. Two major classification: finite automata with output and finite automata without output. And finite automata with output, there are two type of machine: Mealy machine and Morley machine. And without output, we have three types: deterministic finite automata, non-deterministic finite automata, NFA, and epsilon non-deterministic finite automata. So we are going to see one by one, and very importantly, we are going to solve problems in every category. It means that we are going to construct the machine, and we are going to give the input and check whether the machine accept the right input and rejects the wrong input. Fine. That is what we are going to see in every category. So shall we start? Are you guys ready with your notes, your paper and pen? You are going to solve the problems parallelly with me. Anyone, I'll just call by your name or roll number. You are supposed to switch on your video and show me the answers. Fine. So hereafter, parallelly, you are going to solve the problem with me. So whenever I call you, if you are not responding, I'll just notify your name as in absent list only. So keep that in mind. Don't tell me I have not heard. So shall we start?
Yes, ma'am.
Yes, ma'am.
Fine. So first category: deterministic finite automata, DFA. Deterministic finite automata. So DFA is a category of FA under the category of finite automata without output. So I can check the patterns with the machine. And again, it's a simplest method of computations. I have already told you all the types of FAs are very simple, and it's a very simplest method of communication. And um, see, one more thing is, this kind of machines are having very limited memory. Limited memory in the sense, yeah, very limited memory. DFAs are having very limited memory. There is no extra memory like stack, queue, that list. I hope you know about these things. You might have learned data structures. You know what is memory. So that here there will be no extra memory kind of things working for saving my input. And again, we are not going to save the things here. Since we are having only limited memory, we are going to take up a technique of remembering the scanned input. I'll let you know what is how the machine is going to remember the input learned by them. So the thing which you were supposed to know is DFAs don't have any enhanced memory with that. So it has only having limited memory, and it's a very simplest method of computation. Fine. So, and again, if I say finite automata, it means that uh, um, the total number of states is always finite. Fine. So I can able to predict the total number of state for constructing the machine. So that's why it has been called as finite. Fine. So yeah, so I'll just give you the structure of DFA, how it would be looks like, or what are all the variables which we were going to know to construct the DFA machine. So before moving into the problem, I'll just have an introduction about the DFA. So DFA is constructed with the help of, which is defined with the help of 5 tuples, or I can say 5 elements. 5 elements is encompassed in 5 elements are actually um, uh, helpful in constructing the any kind of DFA path. Fine. So you were supposed to know what are all those 5 tuples, and then we will construct the machine using DFA. So those 5 tuples are, I'm just go with one by one, just writing all the 5 tuples. We'll go with one by one. Fine. So for defining a DFA, very first step is a DFA is constructed with the help of this 5 tuples or 5 elements. So totally 5 elements you were supposed to know before constructing the DFA. Fine. So first one is Q. Q is nothing but total number of states in constructing the machine. So total number of states involved in constructing the deterministic finite automata will fall under the category of Q. Q means total number of states required to construct the machine. Just look into this, how it looks like. You have no, guys, I think you have studied this DFA before, right? I,
Yes, ma'am. We had a part of automata theory in APP last time.
so you might have aware of how it looks like. So what do you mean by state? This is how it looks like. Am I right? I like this representation is not new to you since you have worked it before. You might have seen a DFA diagram, that is the construction of DFA. Am I right? Have you ever
Yes, ma'am.
constructed the DFA machine, guys? Yes or no?
Yes, ma'am.
Fine, then it will be easy for me to define the things. I hope you understand. So Q is nothing but a total number of states. So this is how the DFA will looks like this. Look like the edges and uh, the edges which connects the multiple states. And how many number of states in my example? Can you tell me how many number of states were there?
Ma'am, 3.
So 3 total number of states, and it will be represented as Q0, Q1, and Q2. So totally total number of states is 3, and it is represented with Q0, Q1, and Q2. And the second element. So first tuple represent the total number of states in my DFA diagram, and second element Q0. May I know what is the representation Q0 means?
Ma'am, initial
Initial
state.
state.
Exactly, initial state. And how will you know that that particular state is the initial state? uh, During representation, how will you represent the initial state which differs from other states in your diagram? So a state which has inward arrow and with no input symbol is usually represented as initial state. Am I right?
Yes, ma'am.
So finding initial state in the diagram is it will be having an incoming edge without any symbol. So any state which has an incoming edge without symbol is in your diagram, it is called as initial state. So whenever you are going to represent your initial state, that particular state should have an inward arrow towards it, that is incoming edge, without the representation of symbol. Apart from this state, all other state is having the symbol representation and also having the incoming as well as outward edge. Fine. So this is initial state. And one more thing is the one more thing you are supposed to know about initial state is in DFA, in deterministic finite automata, there will be always one initial state. One initial state must be there. It should be never zero nor it should be never zero nor greater than one. So it should be always one initial state towards the deterministic finite automata. So this is all about your second representation, that is second tuple initial state. Any doubts here?
No, ma'am.
Excuse me,
Fine.
ma'am. Ma'am,
Yeah,
an initial state will have outgoing edges also.
exactly. Yeah, you will be having the incoming edge as well as outcoming edge. Just
Okay.
look into this. Yeah. So the third one, what was the third symbol? I think you might have aware of this. Even I have represented this symbol already when I taught you about the basics of automata theory. What was the third symbol?
Collection of strings.
Language.
Exactly. Language or
Collection
alphabet?
of strings.
Alphabet.
Alphabet.
Alphabet. Yes, it is a set of symbols. I have already gave you the definition for this. It is represented as set of symbols, or it can be called as alphabet. So for this diagram, can you tell me what is the sigma value? Just look into my example diagram and tell me what is the sigma value. Sigma is nothing but the
2.
input, right? Input to the state. There are two thing. One is A and another one is B. Am I right?
Yes, ma'am.
And constraint to be remembered for the symbol is it should be always non-empty. There should be at least one representation of alphabet when you define sigma, and it will be always a finite one. So the constraint to be remembered for a set of symbols is it should be non-empty and it should be finite. Fine. So any doubts with sigma? Sigma is nothing but the input symbol which is operating on my states. So when I give one input symbol on my one of my state, it will decide whether to take the input or not, and if it accepts the input, it will move to the next state. Fine. So that is the actually the that is the way the DFA is working. It will accept the input, it will move to the second state. So when I am in second state, for example, Q0, Q1 and Q2. So I'm just applying the input Q0. So whenever you encounter the input B, move to the state Q1. It means that I have told you there is no additional memory. So how it is remembering the things which has been read by the by changing the states. So whenever you change the state, the machine remembers that whatever input has been scanned. For example, currently, if I am in state Q1, the machine knows that I have scanned the input B and I have reached the Q1. Fine. If I am in Q2, the machine knows that I have scanned the input A and I am now currently in the state of Q2. So that's why there is no additional memory required for this DFAs, and the machine remembers the part of input by changing the states. The machine remembers the input by changing the states. Fine. Shall we go to the next representation? F.
Yes, ma'am.
Fine. And the fourth one is F. So F is set of all final states. What do you mean by final state? So the representation of final state is double circle in the machine. Which state is encircled with the double circle in my example?
Q1.
One.
Q1. So in my Q1, in my example, Q1 is my final state. So just underline, I'm just underlining the word set of all. Set of all in the sense, sometimes there may be one more than one final state is allowed in DFS. We will see some examples when it will be required, that is more than one state, when it will be required. So that examples we will see, more examples we will see, don't worry. Just understand that whenever you are designing a DFA, more than one final state is allowed, and also it is represented in the diagram with double circle. So whatever the state which has been encircled with the double circle, that particular state is called as final state. Fine. So it can be empty sometimes, that is uh, uh, there will be no final state can be constructed. It means that machines with no final state will accept nothing. See, understand one thing. When I construct a machine DFA with no final state, it means that that particular machine accepts nothing. Fine. So final state is required for a machine to halt with the input. So whenever your input reaches the final state, then only that particular input will be accepted by that particular machine. Otherwise, it won't. Understand this clearly. If you want your mesh like your input to be accepted by the machine, then the input should cross all the state and it should reach the final state. If the input reaches the final state, that will be accepted by the machine, or it won't, it will be rejected by the machine. Fine. Is that clear?
Yes, ma'am.
And one more possibility is also there. uh, all the states can be a final state. So those type of machines are the one which accepts the universal language, that kind of things. I'll explain it later. So the possibilities of final states are there can be more than one final state, and the DFA machine can be framed with without final state. Without final state means that that particular machine will accept nothing, and there can be more than one final state as well. Fine. Is that clear? Can we move to the last one?
Yes, ma'am.
Yes, ma'am.
Fine. So the last one is sigma. It looks like sigma, the symbol. So this tuple is transition function. So transition function. Um, so transition function. So I'll let you know how to write the transition function with an example. I just want to like the usefulness of this transition function on a state Q. When you apply an input symbol on a state Q means it may be a Q0, Q1, or Q2 in my example. On any state Q, if you apply an input symbol, so it will move to another state. So this is how the representation of transition function, and I'll tell you how to write the transition function with an example. But the fifth tuple is used to represent the transition function. Transition function is the way of writing the state whenever you apply an input to that particular state, which state it is moving. So that is a transition function. If I am applying B, the input B to Q0, where it is moving in my example,
Q1.
it is moving to Q1, right? That is the transition function. So the way to write the transition function, I'll let you know. Fine. Is that clear? All the 5 tuples. Do you understand? So whenever there might be questions, how will you represent a DFA with all the elements, or there may be question how the tuples of DFA will be represented. So you were supposed to explain it with one example. Fine. Is there any doubt with all the 5 tuples?
No.
Fine. So it starts from the total Q I'll just summarize it once. Q, total number of states, Q naught, initial state, sigma, alphabet, the input alphabet, and F, capital F, final state, and sigma representation is a transition function. So this is all about deterministic finite automata representation of elements or tuples. So let me have a justification why this finite automata is deterministic. Why we call this finite automata as a deterministic finite automata. So when the machine will be deterministic. So let me have the justification for the word deterministic. So when the machine is deterministic. So just listen to this carefully. On every state, on any input symbol, we can have at most one transition. On every state, on any input symbol, we can have at most one transition. It means that, see, listen to this. Q naught in with respect to the input symbol B, it is moving to one transition. A transition is different, and with respect to A, it is moving to one transition. So at most one transition is there for every input symbol. Am I right or not?
Yes, ma'am.
So that's why it is called as deterministic. The first point to be justified for calling the finite automata as deterministic finite automata is on every state, on any input symbol, we can have at most only one transition. One transition must be there. Fine. And second one, very important, uh, in every case, the deterministic machine must be complete in nature. Must be complete in nature. So what do you mean by complete? Means for every symbol you must have transitions. For every symbol you must have transition. It means that, see, if you have Q naught, fine, Q naught with respect to A as formed, and if this is my DFA, would you think this DFA is a complete one? This is my DFA, just leave this. This is my DFA. Would you think this DFA is complete? See, the machine is complete whenever every state deals with every input for that machine. So if you take Q naught, the initial state, what is the input scanned by Q naught?
A.
So what are all the two inputs in my sigma, in my set sigma? A comma B. Did the Q naught encounter the input symbol B?
No, ma'am.
No, it means that the machine is not complete. That is not allowed in DFA. Um, Keep this in mind. This is very important. Whenever you construct a DFA diagram, it should be deterministic. If I say it is deterministic, every state should scan every input, every given input. So starting from the initial
Yeah,
state to the
but
final
here
state,
Q naught is not taking the A and B inputs, right? So how is this deterministic?
that is what I'm telling. Q naught is taking A, but it is not taking B. See, Q naught, when applying A, it is moving to Q1, right? So it is not up, it is not dealing with B. That's why I'm telling that this is not deterministic. So I'm just giving this example. This is not complete, so this is not deterministic. You understand? So if I say, if I give any other transition with B, then it will be complete. And for Q2 also, I should give this two inputs. So what I'm trying to say is, any state, if you take up with deterministic finite automata, then the machine must be complete. Complete in the sense, every input must be scanned for every state. You got it? Yes or no?
Yes, ma'am.
So can you tell me when the string will be accepted by the deterministic finite automata? When will the string will be get accepted by the machine? Hmm?
Ma'am, when the input passes through all the states?
When the input or the machine, whenever you are giving the input string, if the machine halted on the final state, the string will be accepted. If the machine halted on the final state, the string will get accepted. I'll give you the example for that as well. And the three things you are supposed to know whenever you solve the problem of DFA is, you know how to construct a diagram with the state representation, and you should know how to draw a transition table, and you should know how to write the transition function. So every problem, you should know how to construct this state diagram, state representation, and then transition table, and then transition functions. So anyway, we are going to see that. I think I have given enough introduction about deterministic finite automata, and you were already you might have aware of those terms. I just refreshed those things. I hope everyone has understood how the deterministic automata looks like, and what are all the constraints to be noted whenever you construct an deterministic finite automata, and why we call uh, it as the finite automata as deterministic. And I have explained all the 5 tuples. Is there any doubt with the introduction of DFA? Shall we move to the problem side?
Yes, ma'am.
Fine. Very first problem, guys, just listen to this. I'll start from the scratch, and we will solve some complicated problems as well. So first problem, construct a DFA, construct a deterministic finite automata for set of all strings start with 0 over the alphabet 0, 1. Shall we solve this case, guys? Are you ready? So you are going to solve with me parallelly. So keep the steps in your mind whenever you solve the deterministic finite automata or any problem. Some of the steps you should follow. You should not go to the things, the center part directly. You are supposed to write what is the input given, and what is the language you are going to frame, and what are all the possible input for those languages, and then you can construct your diagram. Listen to me carefully. So what is the alphabet given here? What is the
0
alphabet?
and 1.
0 and 1.
1.
So can we form the so the constraint has been given in the question. So I'm going to form my language. This is my language. So what was the constraint? With respect to the constraint, can you tell me the possible inputs inside my language?
0, 0, 0, 1.
Yes, the minimal case. See, always starts with minimal case. Okay. So the question here is, any string that starts with 0 should be accepted by my machine. Fine. So what was the least case?
0.
Least case is 0. The input 0 should get accepted, and then 001 will accepted, 0001 will get accepted, and 0001 will get accepted, and so on infinitely. Am I right? This is my language, right? For the given question.
Yes.
So the very first step you are supposed to do whenever you are constructing and whatever the type may be, not only DFA, it may be NFA also. With a given input, you should form your language and you should write what are all the possible input for those language. Fine. Starting from the minimal case. Fine. And I'm going to construct the state diagram. Listen to me carefully. So I'll take the minimal case. This is the minimal case. Always have a state diagram for the minimal case and try to finish it for the all other inputs in my language. Let's listen to me. So how will you see? And one more thing, uh, the naming inside the state is purely user defined. Okay, so I am taking q0, q1, q2. You can take capital A, capital B, and any other type of naming is acceptable. Normally we used to take up this q0, q1 things, or else we go with the capital A, capital B form of representing the states. So anyway you can take it, there is no restriction with that. So I'll any DFA diagram should be constructed with the minimal case. So when you apply 0, it will be accepting to the final state. Fine. So now I took the final minimal case and I have done with the diagram. See, this is the initial state, as I have told you. Initial state with an income invert h with no input symbol is an initial state, and the final state is a double circled it's an a final state. So what is the next step to be done? Is this enough for constructing the DFA diagram? What else to be added for this diagram to make the diagram to be complete deterministic finite automata machine?
One should have a
I need
transition
one
to
more state.
Yes. So for every state, all the inputs to be taken up, and it should be handled in a right way. Fine. So we'll go with one by one. So initial state, I have instructed my machine, whenever you are in the initial state, when you encounter the input 0, go to the final state. Fine. And when I reach the final state, so final state also I have to handle two inputs, 0 and 1. So what I'm going to do is, so after 0, whatever the input may be, my machine my constraints won't fix with that, because my constraint here is just my input starts with 0. After 0, whatever as an input, I just don't care. So I am just putting it in the final state. So whatever comes, just accept it, provided that the first input that has been scanned is 0. That is what is the question. Starts with 0. So the machine will always take up the input that starts with 0. So now I have handled 0, 1 for the state q1. So what about q0? Should I handle the other case also? Yes or no?
Yes, sir.
I should handle it as well, right? Because I have already told you, every state should handle every input. Then only it is called as complete. If the machine is complete, then only it will fall under the category of deterministic finite automata. So I have to handle one. If in a case, initially, when my machine encounters the input 1, then it will come to a state this state is called as dead state or trap state. Why I'm calling this as a trap state or dead state is, see, there will be no connection for the state towards final state. It means that once I encounter any symbol which has been diverted to q2, the symbol, the input will be circulating in the same place, and only the input which reaches the final state will be accepted by the machine. Do you understand now why I am
Yes,
diverting this to q2, which is a dead state, and there will be no connection with the final state? It means that uh, why I am diverting it to the trap state means I don't want my input to be starting with 1. I always wanted my input to start with 0. Fine. Is that clear?
Yes, ma'am.
So don't forget this. Every state, no matter it is an initial state or a final state or a dead state or an intermediate state, whatever the state may be, make sure that your state handled every alphabet, every input in a right way. You should have a transition for every input for every state. Otherwise, your machine is not a deterministic. The complete build up will goes wrong if you have missed one input towards the state. You got it? Shall we go and check how the machines accepts the right input and how the machines rejects the wrong input? Is there any doubt in constructing this DFA? This is a very simple deterministic finite automata diagram. We are going to see more examples, but if you understand this simple diagram, then it is very easy for you to construct any kind of complex machines. Any doubts?
No, ma'am.
No, ma'am.
All of you. Adishri.
Yes, ma'am, understood.
Understood.
Ma'am,
Yeah.
ma'am, can you show that like when 001 and the another input like 0001 and so on,
Yeah.
how these
Exactly.
inputs
I'll
translate into the
yes. I'll just I'll tell you. Ma.
yeah,
So
ma'am.
any doubt in constructing the diagram? No, right? So yes. So I'll just tell you how to construct a transition table for this, and then I'll tell you how the machine will accept the right input and reject the wrong input. Listen to this. As I told you already, whenever you have been asked to construct a DFA, you should construct the state diagram, and then you should draw a transition table. And also sometimes they will give you an input to check whether the input will be accepted by the machine, and that will be proved with the help of transition function. Fine. Just listen to this. How will you draw the transition table? Any idea? So this is how you are going to draw the transition table. In the states should be mentioned in a column, and the input should be mentioned in vertically, and you are going to check it in a matrix like manner. So when sorry, in a state Q0, when you apply A, what was the next transition to be done? What was the next state? Q0 when you up sorry, sorry, the input is 0 comma 1. In Q0 when you apply 0, what was the next state?
Q1,
Q1. So in Q0 when you apply 1, what was the next state?
Q2,
Q2. In Q1, whatever the input may be, the input will remain in the same state, Q1. In Q2 when you apply 0 or when you apply 2, it will be remain in the same state. So Q2, Q2, Q2. So I hope you understand how to construct the transition table. Is that clear?
Yes, ma'am.
Fine. So let me tell you, just listen to this. Uh, I'll write the is there any doubt in constructing the transition table?
No, ma'am.
No, ma'am.
Fine. So transition function, next one is transition function. Listen to me. Whenever I have an input, so how they will ask you the question is, sometimes they will give you their input, or sometimes they will uh, ask you to assume an input to be accepted by the given machine and check whether your machine will accept. Just listen to me. I'm going to check whether the input string 001 will get accepted by my machine or not. Fine. So I'm just writing the transition. See, listen, guys. I will write this transition function for one or two example. After that, I'm not going to check everything. I will just scan through my example, and I will let you know whether the string will get accepted or not. Formally, I will write the transition function here now. Just learn that how to write it, and whenever it has been asked in the question, you are supposed to write the transition function with the given input. Fine. So how you are supposed to write is, just listen to me. So I'm going to prove in the state q naught. Fine. If 001 is to be the input, I should prove that when 001 is applied to q naught, it should reach the final state q1. Am I right? Whenever it reaches the final state only, I can claim that my input will get accepted by my machine. Am I right or not?
Yes, ma'am.
Fine. So we are going to check this. One second. So I take this place. We have some steps to follow. Yes. So I'm going to prove, just cap symbol must be there, q naught comma 001, which is equal to q1. I think we have time is up, just 2 minutes. So the first step is, first each, just take up each alphabet separately and check. Okay, so it start with epsilon. Actually, initially I don't have any input, so the string is empty. When it is empty, it will stay in q naught itself. Am I right? When there is no input, it will stay in the state q naught. Fine. When the input arrives, so q naught comma 0. So q naught comma 0. So if 0 is the first input, then my function will be q naught comma epsilon. Already I have in the state of q naught comma epsilon comma 0. Fine. So I know the result of q naught comma 0. Q naught comma 0 is q naught comma 0. Just see in the diagram, if I am in the state q naught and if I apply 0, what is the next step to be moved after applying the alphabet 0?
Q1.
Q1.
Q1. So I have to check for all each individual input. Don't stop here. Since we have arrived with the equation assumption equal to q1, we should not stop with that. We have to check with the other input also. So the next one is sigma cap q naught comma 0 0. So before 0, we have a input which has we have a state which has been moved to comma 0 comma 0. And we know the result of this transition symbol q naught comma 0. Result is q1 comma 0. In q1, when I apply 0, where you are supposed to where you are standing in the state q1 again.
Q1.
Yes. And the last step, sigma cap q naught comma 0 done, 0 done, and the next input is 1, which is equal to sigma cap of sigma. Sorry, I'm supposed to put sigma. So I have already scanned 0 0 comma 1. So which is equal to, I know the result of 0 0 already, q1 comma 1. If I am in q1, if I apply 1, in which state I will be? In which state I will be in?
I'm Q1.
Q1.
Q1. Any other alphabet to be scanned? To be scanned? Scanned all the alphabet of my input.
Yes, ma'am.
So what is the result? What is the result?
The sequence is accepted.
What is the result? See, I have scanned each one of my input alphabet and I have reached the Q1. It means that if my input reaches the final state, then that particular input will get accepted by my machine. Otherwise, the input will not get accepted by my machine. Yes or no? Yes or no?
Yes,
So
ma'am.
001 will be
Yes, ma'am.
accepted or not accepted?
Accepted.
So do you understand the transition function?
Yes, ma'am.
Yes or no?
Yes, ma'am.
Fine. See, and someone is asking for the rejection as well. I'm just scanning through my input and I'll tell you how the rejection would be. Listen to this. Listen to this carefully. Just look into this. I'm in the state Q naught and I am encountering 1. So what it will do, if it is 1, in which state it will move?
Q2.
It will move to Q2. So after it is moving to Q2, it will check with the next input. It is 0. If it is 0, it will remain in the same state. If it is 0, it will remain in the same state. If it is 1, it will remain in the same state. So till the end of the string, it remains in the same state, and just check the state it is remaining is a final state or not. Is Q2 is a final state?
No, ma'am.
Ma'am.
No, Q2 is not a final state. So what does it mean?
It is not accepted.
So 1001 will not get accepted because it starts with 1. Fine. Any doubts? So anyway, we are going to see more example in constructing the deterministic finite automata. This is just a simple example. So any doubts in DFA?
Ma'am,
Yes.
ma'am, what is the practical?
One second, Kanchan, 1 second. I think only one absent. Mayank is absent, right?
Ma'am, I'm there. Present, ma'am.
I'm here. You are here. I'm calling you for at least 5 to 10 minutes initially. Where did
No,
you
ma'am.
went, Mayank?
Ma'am, in the beginning, I went out for to drink water for 2 minutes. I was there in the whole class.
So you understood all the topics
Yes,
which
ma'am.
we have discussed.
Yes, ma'am.
Venkata Ganesh, number 109. Number 109.
Yes, ma'am.
Do you
Ma'am, actually, I
understand what
came for vaccinate, ma'am. That's why I have to go for vaccination.
you want to go for vaccination, or you came for vaccination?
I have to go to vaccination, ma'am. Appointment is there.
Okay, go. Did you listen to the class? I'm just asking you, did you
Yes,
listen to the
ma'am.
class?
Yes, ma'am.
So you can able to construct a mission. Yes or no?
Ma'am,
Can you able to construct a DFA mission?
I can try, ma'am.
Tomorrow I'm going to give an example for you. Fine.
Okay.
Fine, you can leave. Any other doubts, you can stay back and you can ask your doubts. Rest of you can leave. I will take the attendance from my attendance log. Okay, today. No issues. You can leave.
Thank you, ma'am.
Yeah.
Thank you, ma'am.
Thank you,
Yeah.
ma'am.
Somebody has asked some queries like Kanchan. Who is?
Yes,
Yeah,
ma'am.
tell me, ma.
Ma'am, what's the practical application of this, ma'am?
You were asking about the finite automata.
Yes, ma'am.
See, I have
DFA.
told you, no, very first class, it has been used to check, construct the compilers. See, compilers, whenever you give the input, for example, your simple C language, you just take it. Your compiler is checking for your syntax, right? Whether
ma'am.
the syntax is right for declaring a variable or syntax is right for printing something. So the compilers has been constructed with the help of this finite automata machines. So we have a trained machine which takes the right input, and whenever there is a wrong input, it will reject and it will throw an error. Anyway, you are going to learn about the compiler design in the very next semester in compiler design language. Not only for that, see, I have developed a protocol in network. Fine. I have to check whether the protocol works for the right input. So I can construct a machine for my protocol for checking whether the protocol is working for the right input. Wherever you want to check whether your input is right, and wherever you want to design a machine that accepts the right input and rejects the wrong input, you can go with this finite automata machines. Fine.
Okay, thank you,
And
ma'am.
NLP also, natural language processing.
Ma'am, can you again explain why won't the machine would accept the 1001 input?
1 0.
0 1. Ma'am, why it won't accept this?
So you're asking about this,
Yes, ma'am.
the second input.
Yes, ma'am. Yes, ma'am.
See, 1 0. The question is always my input, my machine should accept the string that starts with 0.
Yes,
Fine.
ma'am.
So here my input is 1001, which starts with 1, right?
Okay, ma'am. So, like,
So
it will
I have
initially reject.
designed a machine